Okay, so what we're going to be introducing starting today, it's going to be a little bit weird because we're reviewing this week and we're going to be doing a retake tomorrow, but we are going to still jump ahead. We need to continue moving forward thinking about this, what we have right here, special right triangles. And so that's the name of the document you have downloaded. And special right triangles are, as you might imagine, they are right triangles. And this is a special right triangle. You can see at the top it's called a 45, 45, 90. And and like I was saying, special because it has to specifically be a triangle. Why are we calling it a 45, 45, 90? Yeah, those are the degrees. 45 degrees, 45 degrees, 90 degrees. And that's what we're looking at here. So now this one's special because let's see how we create a 45, 45, 90 triangle. We just take a square and we draw a diagonal through the middle. And one thing, if we think about our quadrilateral properties, a diagonal in a square is an angle bisector. So that means instead of 90 degrees right here, we're going to cut that in half. It's going to be 45 degrees and 45 degrees. Same thing at this end. So a 45, 45, 90 triangle is really just a square that's been cut in half diagonally. And it might seem like a special case because, how often do squares come up in the real world? But mathematically, this does come up quite a bit, especially if you consider about working on a coordinate plane where you move over and up and, it's just made up of a bunch of squares. So this is a common right triangle that you see mathematically. And this is also something, what we're going to be doing is we're going to be learning some rules and some shortcuts when you have this specific right triangle. And I say specific as far as the degrees, not the side lengths. And later in your math career, you're going to be learning about what's called the unit circle. And in the unit circle, these rules that we're going to be looking at with 45, 45, 90s, they come up quite a bit. So if you know these rules and you can commit them to memory and work with them, you can do your math a lot faster this way. So it's kind of, you learn your multiplication table so you can do your multiplication a little faster. Even though you have the calculator, you could do it by hand. Ideally, you can do the mental math and make it go faster. That's kind of what special right triangles are for. So we're going to start by doing it the long way. We're going to do some Pythagorean theorem. And what I've got here is, I'm going to look at this triangle on the left. And it's a 45, 45, 90. We've got that. But it's got a side length of 10 and 10. Now here's one thing we know about special right triangle, the 45, 45, 90, is that the two side lengths have to be congruent. Because, I'm not talking about the hypotenuse, but these two, if you want to call them like your A and your B side, they have to be congruent because this is just a square that's been cut in half. And squares always have congruent sides. So work with that idea. And so if this is my A and this is B and the C is always opposite the right angle, then I can do Pythagorean theorem here. So A squared plus B squared equals C squared. And I can substitute in. A in this case is 10. B is 10. And C is my x that I'm solving for. So what's 10 squared? All right, we're going to do this kind of monotonous sort of Pythagorean theorem a few times, and then we're going to figure out what else we could do here. 100 plus 100 is?
200.
All right, now we are going to do what? Square root that. And this is where we go back to, and hopefully today you realize why we were practicing with all these radicals and the operations here. We want to simplify this. I don't want to just plug this in the calculator and get a decimal answer. So what is my biggest perfect square factor of 200? 100. All right, so this is the same as 100 square root of 100 times the square root of 2. And that means my final answer right here is going to be what? Now remember, we got the perfect square factor of 100 so that we can get the square root of it. And what is the square root of 100? 10. There it is. So 10 square root of 2. All right. Now this is a bunch of work, but in the end I get 10 times the square root of 2, and that's centimeters right there, so I'll write that in. And here's a good thing. If we have a 45, 45, 90, we can solve it every time with Pythagorean theorem. Let's do it one more time this way and see if we can come up with something. And you guys might already have an idea of what kind of rules we could work with here. The next one, it's going to be more of the same. So what's my hypotenuse in this next problem? One of the 6's or the x? X. Okay, so that's the only thing that really matters. And both of these are the same, so I'll just call them A and B. So I got 6 squared plus 6 squared equals, well, it's not C, it's going to be x squared. 6 squared is 36, so yeah, we've got that twice. No, not plus. Equals x squared. So 72. And the biggest perfect square factor of 72 is? I know I'm going through this a little fast. 36. The biggest perfect square factor is 36. So that's going to be square root of 36 times the square root of 2 equals x. And again, my final answer for this is going to be what? 6 square root of 2. All right, so far so good. I hope I wasn't going through that way too fast for you to follow along, because it's Pythagorean theorem. So looking at what we got with these first two, I have side lengths of 10 and a hypotenuse of 10 square root of 2. I have side lengths of 6 and a hypotenuse of 6 square root of 2. I bet you guys can probably tell me. I've got side lengths of 2. What do you think the hypotenuse is going to be? What pattern? What is it? 2. There it is. 2 square root of 2. All right. Now we can confirm this, and I'm going to go. Let's go through it really fast. So it's going to be 2 squared plus 2 squared equals x squared. So that's 4 plus 4. So I now have the square root of 8 equals x. Well, the biggest perfect square factor of 8 is 4. So that's square root of 4 times square root of 2 equals x. And the square root of 4 is 2. All right. Now, I apologize if that was a little bit fast running through it, but we just did Pythagorean theorem 3 times and came up with this pattern that seems to show up over and over again. That if I've got a side length of some number, the hypotenuse is just going to be that number times what? Times square root of 2. All right, so let's come up with our general rules. Let's stop using Pythagorean theorem for 45, 45, 90 triangles. And what I'm going to do up at the top of the page is I'm going to draw a generic 45, 45, 90 triangle. So what I'm doing is I'm essentially taking this lower left half of my square, and I'm just going to pull it over here. And let's just focus on that 45, 45, 90. So here's a 45 degree angle. Here's a 45 degree angle. And this is a generic 45, 45, 90. So rather than saying a specific side length, this is just going to be length x. So if this is length x right here, what does that mean about this length right here? It's also going to be x. These are congruent. I should separate this a little bit, so I'll just draw a line kind of separating those. All right, so these two are congruent. And this is going to be the easiest thing. You're going to see some examples here in a little while where you're solving for two side lengths. That's one of the benefits of a 45, 45, 90, a special right triangle also, is that I could give you one side length and you can solve for the other two. It doesn't work that way for a typical right triangle, but it does work that way for a special right triangle. And that means if I only told you one of the sides, really easily you could tell me what the other side is going to be. It's going to be exactly the same. The hypotenuse in this example is going to be what? So, just to clarify, if I've got a side length of x, what is my hypotenuse going to be? So x times what? Square root of 2. All right, so this is our generic, these are our 45, 45, 90 rules. Okay? This contains all the information you need to know about 45, 45, 90 triangles. So, two side lengths are congruent, and then you take the side length, multiply it by square root of 2 to get the hypotenuse. Now, it works the same in reverse. If you know the hypotenuse, you divide by square root of 2 to get x. In fact, I'm going to write that down. Let's see. I'm going to change the color a little bit. So if I know the side length and I want to solve for the hypotenuse, all I'm going to do, like I just said, is I'm going to take my side length and I'm going to multiply it by the square root of 2. The reverse is also, the reverse can also happen. Let's say you're given a length on the hypotenuse and you want to solve for the side length. Okay, so notice I drew this arrow going the other direction. In the first case, I knew the side length and I was solving for the hypotenuse. Now I know the hypotenuse and I'm solving for the side length. What's my calculation going to be? Divide by square root of 2. So, of course, we're going to spend the rest of class going through a number of examples with this. But I want your takeaway from this to be that if it's a 45, 45, 90 triangle, and visually you should be able to tell compared to other right triangles. But if you have a 45, 45, 90 triangle, the only thing you need to kind of decide between is, am I multiplying by square root of 2 or am I dividing by square root of 2? Do I know the side length? Well, in that case, I'm multiplying by square root of 2 to get the hypotenuse. Do I know the hypotenuse? Well, in that case, I'm dividing by square root of 2 to get the side length. So we're inverse operations going on. All right, any questions on this top part? All right, we've got some 45, 45, 90 rules, and let's apply them down to here. Now, before we do any problems here, I want you to look at these and tell me what you notice about all 6 of these problems at the bottom of the page. We're missing side lengths. We have the hypotenuse, we don't have the side length. And we're going to see these get progressively more challenging, but, I mean, hopefully they're not that bad, and you can kind of, if you feel like you can get through these 6 problems, then it's not going to get really significantly more challenging from there with the 45, 45, 90. All right, so let's look at this. The very first one, we've got a hypotenuse, and it's 8 square root of 2 for the hypotenuse. So what do we do to get the side lengths? Okay, divide by square root of 2. So if you, and maybe I just have to keep saying it because it's really, really important that this idea gets across. If you have the hypotenuse, you have to divide by square root of 2 to get the side length. Okay, and that makes sense. Just think about the fact the hypotenuse is longer, so we're going to divide in order to get that smaller amount. Okay, so divide by square root of 2, and it's important to remember it's division because this is going to work out very nicely. 8 square root of 2 divided by square root of 2, what happens here? Yeah, they cancel out. And you're left with just 8. So in this case, I've got side lengths of 8 centimeters. And what's the other one going to be? 8. They're congruent. So notice we're solving for 2 lengths. On your test, let's say you make a mistake in your calculation and you come up with a different number, whatever random number you get here, but you show that both these are the same, you'll at least get credit to say, okay, you knew that both of them were supposed to be congruent, even if you made a calculation error. So you'll get partial credit. All right, the next one we should be able to do pretty quickly. Okay, yeah, and I just heard the answer is 3. And we can see that real quick. It's a hypotenuse. So for all of these, we're going to be dividing by square root of 2 to get the side length. And now we got 3 square root of 2 divided by square root of 2. Same thing happens with this problem. You cancel those out, and you're left with 3. So I got 3 centimeters here. I got 3 centimeters here.
Always be the square root of 2 you're dividing by, or it could be different?
For 45, 45, 90, it will always be square root of 2. You're either going to multiply it or divide by square root of 2.
When would it not be?
When you have a different special right triangle. We're going to learn next week our other special right triangle, and those have different rules. Okay. This one right here, the next one, we have a hypotenuse which is square root of 8. So, what's my operation? All right. I'll just keep asking you guys, but it's a hypotenuse every time, so we're always dividing to get the sides. So, this one isn't too bad. Square root of 8 divided by square root of 2. What's that going to be? Square root of 4. We learned about these operations, and when they're both like terms like this, where they're both radicals, you can just do the straight up division. Square root of 4. Now, what is the square root of 4? 2. There you go. Look, it sounds like you guys are getting the hang of that one pretty well. So 2 centimeters here, 2 centimeters right there. All right. Next one just looks a little bit different. But let's tackle that one. Any questions on that one we just did?
Times 2, 1.
I didn't. No, we didn't do any multiplying by 2. All right, hypotenuse again. So to get the side length, we divide. All right. So we just take that number, 5 square root of 6. Divide by square root of 2. And what is this going to be? Okay, 5 square root of 3. Now, to make sure that's really clear, now, you can probably see what's going on. We're just taking the radicals and dividing them. But if it's helpful to show it this way, because sometimes you're saying like, well, why don't we mess with that 5? Think about it like this. I'm going to erase real quick. I'm going to rewrite this as 5 over 1 times square root of 6 over square root of 2. I could rewrite it that way if I wanted to. It's not really necessary, but it does help to illustrate that this 5 is still kind of just hanging out. It's just doing its own thing over here. And we can divide this, and it doesn't affect the 5 at all. So there's where we get our 5 square root of 3. right. It's my jam right there. Okay. All right, now we get to the one which is the most, and I say most challenging, but I don't want you to get too worried about it because we've been practicing with our radical operations. All right, so we're dividing by square root of 2. It's still the hypotenuse. We're still solving for the side length. Now we've got this weird situation where it's 8 divided by the square root of 2. And what do we do in this situation?
Just 8 over the square root of 2.
No, we got to do something else and multiply by what? Close. There you go. So this is what you guys were practicing with on Tuesday, and this is rationalizing the denominator. We do not want to leave it this way because we got a square root of 2 in the denominator, and you'll never see that as an acceptable answer. So we need to rationalize. Take that square root of 2, multiply by that number over itself. All right. And of course, this is about as difficult as rationalizing the denominator gets. We'll rationalize a slightly different way with our other special right triangle, but it doesn't get super complicated. So with a 45, 45, 90, you're going to be multiplying by square root of 2 over square root of 2 when you need to. There will be a lot of times where you can just do the straight up division, and you don't need to worry about rationalizing the denominator like in the previous example. But here, let's just go ahead and, we'll see that we have to rationalize. So we have 8 times square root of 2 on the top. What's the denominator?
2.
It is 2. I'm going to show, first of all, it's square root of 4, but you guys are right. So that's 8 square root of 2 divided by 2, because now that square root of 4 becomes 2. And what's my final answer going to be? 4. Yeah, 4 times square root of 2. Again, I'll erase this and I'll make it really clear. That's the same as 8 divided by 2 times the square root of 2 over 1. And there's where you can do your 8 divided by 2, get 4 square root of 2. Okay. So that's what we've got for this 45, 45, 90. Go ahead and try that last one, and we'll make sure we all got the same answer here in a minute. Okay, it looks like most people are finishing up on that. What is the answer here for x? What is it? 3 square root of 2. Was everyone able to get that? Okay, good. Now in the Google Classroom, you'll notice another assignment posted, which is 45, 45, 90 practice. There's version 1 and version 2. Go ahead and download version 1 right now. And you'll know if you got to it because it should look like, I believe it should look like this. All right, so this is just, as you might imagine, it's just a bunch of 45, 45, 90 practice. The difference between this and what we just did, those were all the hypotenuse given, and we need to solve for the side lengths. But look at these. You've got all these situations where there are different side lengths given, and you need to solve for the other two. And that's how it works with the special right triangles. This is basically what your quiz is going to look like to a large degree. So if you've got, for number 1, square root of 2, is that a side or the hypotenuse? It's a side. So solving for one of these should be really, really easy. What is y going to be? Yeah, it's exactly the same. You don't even need to do any calculations on that. But if I'm going to get the hypotenuse, what do I need to do? Now we're multiplying that side by square root of 2. All right, so we haven't had to do this one yet for a problem, but now we can see we've got the side length, square root of 2, times square root of 2, and that's just a fact about special 45, 45, 90 triangles. They just happen to be the same number in this case, but it normally doesn't work out like that. So if I multiply by those together, what do I get?
2.
Yeah, 2, which is square root of 4, which simplifies down to 2. So x here just equals 2. Okay, now there's a lot of examples on here. Is there any in particular you guys want to go through, or do you feel like you have the hang of it? 8. Okay, yeah, 8 looks a little bit tricky, so let's look at that one real quick. They give us 9 square root of 2 over 2. Now, first of all, is that the side or is it a hypotenuse? Side. So we know what one of them is going to be. V is the same thing. And I hope that that's at least a little bit of comfort for you. So if you have a problem like this on the test and you mess up the calculation, you'll get one of the two right. All right, but since we know the side we're solving for the hypotenuse, we're going to do what? Multiply by. All right, and it just really needs to be pounded into your memory that it's always multiplying or dividing by square root of 2. It's the only calculation you ever do with a 45, 45, 90. Okay, so now we've got 9 square root of 2 over 2 times the square root of 2. Now I'm going to think of this as the square root of 2, there you go, over 1. So if I multiply that out, what about having the numerator? 9 square root of 4, and then the denominator is just going to be 2. All right, and then simplify from here. We know the square root of 4 is 2, so it's 9 times 2 over 2. And we can pretty easily see what can happen here. What can we do with that?
9 times 2 is 18.
Yeah, we could multiply it out and get 18 divided by 2. We could also just cancel out the 2's at this point when we're multiplying and get our answer of 9. But if you like to multiply it out, get 18 and then divide by 2, no problem. So my final answer for the hypotenuse is going to be 9. All right, those are the two. Any other problems on here you guys want to have a look at? You've pretty much done every type of problem that you could possibly have. The numbers might change a little bit. Let me see if there's one that's really nice and challenging here. Oh, how about number 19? You guys want to try that one?
Yes.
Okay, so let's do that. Let's just say it's the hypotenuse. We need to divide by square root of 2. Hopefully you guys are good with that. Yeah, we're going to divide this by square root of 2. So, 5 square root of 3 over 3. Now, I could do something like this. Divide by square root of 2. That does not look very pretty. Remember, dividing by square root of 2, another way we can think about that is the same as multiplying by 1 over the square root of 2. All right. So if we're good with that, we at least have a path forward. We can proceed and kind of see what to do from here. So you've got 5 square root of 3 over 3 square root of 2. And what do we do here? Well, yeah, we're doing that. So what were you saying? multiply it by, remember, all we're going to do at this point, because that is technically our answer, but we don't like the form that it's in. So all we're going to do is multiply by square root of 2 over itself so we can rationalize the denominator.
So square root of 2 over square root of 2.
Yep. And you actually had problems almost exactly like this on your practice with rationalizing. So just think back to that. If you were comfortable doing it before, there's no difference in the process at this point. So what is my numerator going to be after I multiply across? 5 square root of 6. And the denominator is
5 square root of, it's just square root of 4.
3 times square root of 4. And we did this because we know what the square root of 4 is. And what is that? So I've got 5 square root of 6 over 3 times 2.
Do it one more time, it'll be 5 over.
So 5 square root of 6, we'll keep that the same. What's my denominator now? 6. Can I simplify this in any way? No, at this point we are done. That is the simplest form of our answer. So it doesn't look very nice, but you could have problems like this. So that's about as complicated as it gets. Questions like that. Okay, so everything else you should be able to handle on this. Make sure you're practicing with this. We're going to look at our other special right triangle next week. So you're going to have a little bit of gap between now and coming back to this. So make sure you don't forget what we talked about today.